My name is Holden Mays, and this is my video lab report for Lab 4 for Physics 2212 at Georgia Tech. This video will cover the lab in 5 sections, starting with an introduction to the lab, followed by an explanation of the portion of the lab covering series circuits, an explanation of the portion of the lab covering RC circuits, an experiment involving an RC circuit, and ending with discussion questions about the lab. The goal of this lab was to learn the behavior of ohmic resistors and capacitors in order to predict the behavior of circuits containing resistors in series and parallel, and the behavior of RC circuits using the principles of energy conservation and current conservation. Using a simulation, we will observe the behavior of circuits and compare that behavior to our prior knowledge about how circuits should behave. Using wires and ammeters with negligible resistance, we can observe how resistors and capacitors affect the current and voltage of circuits. The laws most relevant to this lab are Ohm's law, which states that the difference in voltage between 2 points is equal to the current multiplied by the total resistance between those 2 points. The loop rule, which states that the change in voltage around a loop in a circuit sums to a total of 0 volts. And the node rule, which states that the current leaving a battery will be equal to the current entering a battery. The first experiment involved creating a circuit like the one shown here with two 1.5 volt batteries. When the circuit was closed, the current running through the circuit was a constant 0.02 amps. When the top ammeter was replaced with a voltmeter, the current fell to 0 amps, and the voltage difference between the positive end of the batteries and the now disconnected wire was -3 volts. This was because the voltmeter's resistance was so great that the current flowing through it was negligible. When the circuit was closed, a voltmeter was used to record the voltage difference between many pairs of points depicted in the picture on the left. The results are recorded below, and a graph depicting the results is also shown. The loop rule can be observed in how the sum of the voltage readings throughout the circuits is 0 volts. The voltmeter doesn't change the reading on the ammeter because the resistance in the voltmeter is greater than the resistance in the resistors by enough that the current flowing through the voltmeter is negligible. Conversely, when an ammeter is run parallel to the 100 ohm resistor such that the current is given a path around the resistor, every ammeter read 0.06 amps, meaning that the current is greater than before. This is because the current was provided an alternate path of much less resistance, so the current flowed around the resistor while the negligible current ran through the resistor. Using previously acquired values and Ohm's law, the resistance of several elements in the circuit were calculated and recorded below. The results are fairly accurate, though there are minor discrepancies resulting from rounding errors. When a light bulb is connected to a resistor-capacitor circuit, it glows bright, then dims as the capacitor is charged until the bulb no longer glows. When the battery is then removed, the capacitor loses its charge and the bulb glows again, dimming until the capacitor is uncharged. In both of these situations, the current starts off large, then approaches 0 amps as the capacitor is charged or discharged respectively. It took 15.6 seconds for the 200 millifarad capacitor to become fully charged and discharged when the light bulb had a resistance of 10 ohms, and it took 30 seconds for the 200 millifarad capacitor to become fully charged or discharged when the light bulb had a resistance of 20 ohms. The time constant, RC, of a circuit with a capacitor is the time required for the capacitor to discharge until only about 36.79% of the original charge remains. The RC of a circuit consisting of a 9-volt battery, a 30-ohm bulb, and a 200 millifarad capacitor can be found experimentally by plotting the natural log of the voltage difference across the capacitor over the initial voltage difference across the capacitor against time. The RC of the circuit is equal to -1 divided by the slope of the graph. The RC of the circuit described above was 6 seconds. If a real ammeter was used instead of an ideal simulated ammeter in the lab, the currents observed during the lab would be slightly lower since a real ammeter would likely have non-negligible resistance. If a real battery was used to charge a real capacitor in the absence of an explicit resistor, The wires making up the circuit would be considered to have non-negligible resistance, resulting in the capacitor charging or discharging very quickly, but not instantaneously as it would in the simulation.